networking devices. So first device is important device is hub. Okay, in the networking devices, we'll start from hub, repeater, hub or a repeater, switch, router, bridge, modem. Of course, there is certain other things also there, like a firewall, CSU, DSU units, IPS, IDS, IPS units, ETE, DCE type of device things. Those are not devices, just the words. Later, if you are try to find what it is. Okay, I don't teach I tell, but I will tell only about a hub first of all. Hubs, switches are important, router is important, modem is important. Okay, and of course, I will we will discuss. Meanwhile, we will discuss about a Wi-Fi router. It is. So, can you see this is hub or a repeater? Okay. Hub is suitable for LAN communication, small networks. Hub is a suitable for a LAN communication, small networks. Repeater, repeat the signal to communicate for long distances. Again, switch is same as a hub. It is a LAN device. Small and large networks, MAC learning. Okay. Routers used for both LAN and WAN communications. It is inter-networking devices. It will tell you how to reach the destination. Modems are used to connect internet, okay, or a ISP to connect ISPs or internet. So you connect ISP for an internet purpose only, right? So your modems are used to connect your ISP. Okay. Next, yeah, firewalls, VPNs, and other devices also there. So I didn't add that kind of stuff. So VPN device is also there. Or sometimes firewall has a VPN. So differences and small point wise, it is available there. This is good. Now we can reduce the size also. Guys, hub. You know how hub is look like. So you can put a networking hub. Put a networking hub. So these are the hub how it is look like. So it is a device which we connected to our network. Okay, like this. It contains a ports and there is a power connection and switch is also there. So You can see the switch on or not. Like yesterday we discussed about a star
What is the
topology.
difference between hub and switch?
Switch?
What's the difference between the hub and switch?
Yeah, I will tell. Okay.
Networking. Okay.
So yesterday in star topology we have seen hub and switches. So this is how hub is look like. We connect cables directly to this hub from your devices like your laptop or a desktop with wire LAN connection. We connect it. So to create a simple LAN network, we are using this hub or a switch. Okay. Okay. This is you can see there is something is going on right like this. So what happened? This PC is actually sending a message to someone, some of this PC. So, but what happened? So this packet reaches to hub. Hub don't know where is the destination. So it will send to every port which is connected. Every port which is connected there. Okay, that is how hubs work like that. So you can, this is another diagram. You can see routers, switches, hubs like that. Yeah, I will explain what is a hub, guys. It is not a intelligent device. It does not understand what is MAC address or an IP address. Okay, these points are not required, like or what it works with the bits kind of stuff, not required. Okay. It broadcasts packets to every device in the network. So that is called a broadcast domain. I think it is already there. So we'll see that one once it is in there. Okay. Shared bandwidth, this is a difficult to explain. Okay. We use it for a LAN communication. It is suitable for a small networks. Why? Because of it is, I need a big size, means like this. Okay. It is suitable for small networks. As per OSI, it is a layer 1 device. It is a number of collisions are occur. Okay, more number of collisions are there. More number of collisions are there. So then more packet loss. More packet loss in it. Okay. Yeah, I didn't add that broadcast domain kind of stuff, so I will add it here. Which is a broadcast domain. Which is a broadcast domain. So why it is called as a broadcast domain? It broadcasts packets to every device. Okay, whenever it is received a packet, whenever it is received a packet, it broadcasts to every device which is connected in the network. This is the thing I showed, right? Okay, so one I know you are not getting, right? I will tell. Guys, this is a hub. I have a PC and I have a PC. I have a PC, of course. So like that. In any case, so not required more PCs anyway. I have these computers are connected or laptops are connected to a hub in a simple LAN network it is. So it is APC, BPC, CPC and D and EPC. I'll use it later, this one. Okay. Look at here. I want to communicate A to B. Are you telling something? Okay, now. Okay. If in case you want to send a packet to A to B, so how packet is travel? A send a packet to this hub. Hub is send a packet to B and C and D and E. What happened? Okay. Meaning is just I want to send a packet to A to B, but the packet reaches hub, hub will distribute it to everyone. So this is called a broadcasting. Next, everyone received a packet, right? Everyone received a packet, but this CPC check, I'm a destination. Who is the destination? B. C is not a destination. What C will do? It drop the packet. What E will do? It drop the packet. D will do? It drop the packet. And B accept the packet because that is the original destination. Happened guys, still not completed this part. Okay. Understand guys what is meant by broadcasting? And it keep goes on like that. For example, C want to send a packet to A. Same goes. C send a packet to hub, hub to B, and D, and E, and of
So
course
router
E.
multicast the data packets, right?
What happened?
Hub, sir, hub broadcast the packet and the router multicast the packet.
No, no, so don't add router here. So yes, right. That is the point.
Okay, sir.
Hub broadcast the packet to everyone. It's a broadcast domain. So whenever the packet receives at hub, it broadcasts to everyone. Yes, it broadcasts the packet. Very good. Okay.
Okay, sir.
If you add
Thank you.
router here, then again it will confuse the hub. Okay.
Yes, sir.
So
Yes.
that's why we split it. Okay. And hub
Okay.
is mainly um, there is no multicasting. Okay, multicasting is not there. Okay. Hub is also used for a LAN communication. Switch is also used for a LAN communication. But in a hub, what happening? It is broadcasting. And what happened in the broadcasting? C received a packet from A. For example, you take a D. A to A sending a packet to B. Same time, C send a packet to A. Now D receives A's packet and C's packet also. E also receives A's packet, E's packet. Okay, B receives A's packet and as well as a C's packet. A is sending a packet as well as it is receiving a packet from C. Okay, so what happens here? More broadcast will occur, so then more collisions will occur. Means I am traveling and I'm receiving. At the time of receiving, I'm receiving from multiple resources. Even it is not my main packet. Okay, not my main packet. What happened? More collisions will occur. More traffic is generated. More traffic is generated. More collisions will occur. So then packet data loss possible. That's why I said hub is a Hub is a
network traffic also increases.
okay. Hub is suitable for a small networks. And of course, we are using LAN communication, but it is a suitable for small communication because it is a broadcast domain, meaning is it broadcasts uh, packets to every device in the network. Means those devices are connected, it will send it. Okay. Next one is it is a not intelligent device, meaning is it does not understand no circuit kind of stuff for understanding MAC addresses and IP addresses. Nothing is there inside. It is a layer 1 device. Layer 1 device, as per OS layer 1 is a physical layer. The physical layer is all about bit stream, electrical signal, this kind of stuff only. It's not about a MAC address or IP address. That's why it is suitable for, so that's why it is, we call it as a LAN layer 1 device. Number of collisions are occur because of this broadcasting, key broadcasting domain. It is a packet loss. And of course, when you say broadcast domain, and it is a collision domain also. So some people put a, as per CCNA thing, it is a single broadcast domain and single collision domain. It is. The collisions are occurs mainly at hub side only. Okay, at main hub side only it is. It's a single broadcast domain and single collision domain. And you say multi, right? That is switch. Switch is a single broadcast domain and a multi collision domain. Okay, so okay, so that is good. Okay, this is basic things of your hub. And there is a repeater is also there. What is this repeater? Repeater repeat the signal again. For example, your basic cable, your UTP cable, maximum length is supporting length is 100 meters. For example, in my building, I want to create a LAN and one floor to another floor. There is a lot of distance is there. First floor to 10th floor, lot of distance is there. My cable, direct cable is not supporting. I want to connect from first floor to 10th floor or 20th floor. Direct cable is not supporting, right? Directly can't put a cable here. 100 meters is our UTP STP cable limit. If it is a OS means fiber optic cable, then maybe you can put a 10 kilometers also. Depends upon the cable and their reflection methods and all. But here it is, they use a repeater. No, this is a repeater concept is not new. If you know our olden days, cable TV network. So cable guy put a repeater. Cable guy put a repeater like because of he given a one main cable, from cable it is distributing internet, right? In certain distances signal become weak, more distortion, more dots on the screen. What he will do, he'll install a repeater and connect the power connection there. So from that one onwards he can communicate further longer distances. So this is called a repeater. The original repeater is look like this one. Okay. So these are Wi-Fi related repeaters, but this is the repeater. Okay, you can see two connections are there. One is from, and this is for a two. Okay, incoming and one is outgoing. This is a repeater. So this is devices are there. It repeat the signal. Of course, you can use a hub instead of a repeater. Any single repeater is there, then you can able to tell the Ethernet repeater one connection only. a picture is there. I missed that picture. These are the different symbols, guys. These are the different symbols: hub, switches, repeaters. Okay.
So basically, it boosts the signal.
Yeah, of course, but small difference is there.
Okay, sir.
Boosting means like you have an amplifier. If you have an amplifier, so then if you say boosting means a small signal become small audio signal become higher, right? Means big
Yes,
audio
sir.
signal, right? That is a boosting amplification. Repeater does not um, amplify the signal. It does not amplify the signal. It just repeat the signal. Okay. So signal strength, same signal strength as original signal strength is there, same signal strength. You don't increase the signal strength. Okay. So that is. And of course, hub is also act like a repeater. Hub is also act like a repeater. Okay. You can use hub instead of a repeater. Next, nowadays, have you seen a repeater? Of course, as a Wi-Fi extender, as a Wi-Fi extender, like this. You have a Wi-Fi router. After certain distances, your Wi-Fi router become weak, right? Wi-Fi signal become a weak, right? So in generally people, the internet guy install the Wi-Fi your router in the hall. But once you are into the bedroom or if your room is bigger, okay, if your room is bigger, then what happen? You cannot able to you cannot able to get a proper full signal. You won't get it. You will get only 1 point or 0 point kind of stuff. So what we will do it? We install the this Wi-Fi repeater, okay, Wi-Fi extender. So we have to calculate. This is my Wi-Fi router. This is my laptop or a mobile phone. So I will check where the Wi-Fi signal is good and up to good point, like at least 1 or 2 points it is there. Okay. Then I will install a Wi-Fi extender. Then also check the this distance. It is this distance and this distance must be not same, must be accurate. Means I should get a full signal. I should get a full signal, and here the signal is become weak and receive the weak signal and make it as a normal signal. Again, it will stand. You don't boost it is again same signal only it is repeat. But at this point, you put a laptop, you will receive 1 point or 2 points only. But now you are getting full signal. So full signal strength you are getting. So that is the main point of Wi-Fi extender. You can take any Wi-Fi extender. So many Wi-Fi extenders are there. Okay, original picture I didn't take in. So if you want, you can add a Wi-Fi extension also. Some people are giving some kind of ideas nowadays. I don't know whether it is works or not works kind of stuff. Okay. Maybe in future you have to use compulsory this Wi-Fi extender kind of stuff. It's become very big one. This is enough.
The difference between
Tell me.
the difference between wireless Wi-Fi and cable Wi-Fi.
Cable Wi-Fi.
Yes,
That's not cable Wi-Fi kind of stuff. You are using cable, it is a wired.
cable, sir.
Yeah, cable type of network and wireless network, right? Wi-Fi type of network or a cable-based network. Now we are in our home, we are using Wi-Fi internet, right?
Yes.
Wi-Fi routers we are using, okay? And
Yes,
cables. Cables are standard, guys. Like whatever it is, this is a unit which connects to the internet that is outside. I have a desktop, okay? So you can connect to through wire. Now I have a laptop in our office. Because of this Wi-Fi signal is weak, then there is a cable facilities there. So I connected through cable also. But here it is, the distance is limit based on the length of the cable. It is based on the length of the cable. Okay. But 100% signal strength will be there. So even it is a limited, so no need to wait for a radiating signal, username, passwords and all. It is more secure. Just try connect and you can start using it. But in our home, the Wi-Fi router having limited ports. Again, you have to use the switches to connect wired devices. Next, not all devices are wired type of
Sir,
connect.
hub is
Yeah, tell me.
sir, hub is operated on which OSI layer in OSI
Wi-Fi
model?
router
Like sir, in which model like in which layer it is operated? Like in data link layer or in physical layer?
or Wi-Fi router.
Okay, sir.
Which one you're asking? Wi-Fi router is, of course, Wi-Fi router is mainly in a network layer, layer 3, because it understands IP addresses, routed protocols, routing protocols. So you have to tell it is first main important is operates at the network layer.
Okay,
Sir,
sir.
sir, you told about the collision in the hub. So that collision just destroys the electrical signal, or like we can still like
Packet,
enter.
packet,
Yes,
packet.
sir, packet,
Mhm.
or like we can receive it on the other end even after the collision.
Not always destroy, right? So, for example, there is a traffic signal, right? You understand maybe this is a more normal example. Like forward junction, there is a traffic signal. What you will do, you have to always go through left, then you can take left or you can go straight. If signal is open, then you can go to like this only. Now the traffic signal and the traffic constable want to take a leave for a day on Monday or Friday or Tuesday, something like that. What happened? Everybody want to go like this, right? Same direction. So I want to go right, left, and some other people also want to come into right and left. These people also want to go. What happened? Collision occurs. Not 100% collision. Some people can easily pass. Some people can able to stay there only and fight in the middle of the road. Yeah, yesterday it is happened. One guy suddenly stop at road and talking to someone. That is the point. Okay, I think there is some other issue. That's why he stopped there. Okay, so it is. We are going like this. So maybe you will go very easily. Okay, sometimes there is a blockage. So collisions occurs. So the packet are destroyed or a packet loss is there. What is a disadvantage of that one? Guys, here communication works like this. A source is send a packet to destination. Destination received a packet and then destination will tell to the source, yes, I received a packet. For example, you send a packet to A to B. You send a packet A to B. So B received a packet and B tells, yes, I received a packet. Then A understand B received it. That's it. If in case you send a packet A to B, B didn't give any acknowledgement. So then A think B didn't receive it. What A does, it will send it again. A think it will send it again. How many times it will send? So whenever the B send an acknowledgement, yes, I received a packet, and A received acknowledgement from B, then yes, okay, B received a packet, so no need to send it again, same packet. Okay, so what happened in the collisions? B may not be received a packet. If it is not received a packet, then it don't send an acknowledgement. A will send a packet again. This is one scenario. Second scenario, A sent a packet, B received a packet, but failed to, B send an acknowledgement, B send a acknowledgement, B received a packet, B send a acknowledgement to A, but A is not received because of that packet is got collided. Now A thinks B not received a packet, again it will send again. Now what happened? Lot of packet data loss will occur. 100% data communication will stop. It is not there. So sometimes packet delivers successful. Sometimes packet may destroy. Okay. So what happened? Again we have to send. Then more traffic will increases. That's why I said hub is suitable for small networks. You have a 5 devices, good. 4 devices, 5 devices, good. 8 devices, good, no problem. Okay, but you have a 20 devices, 50 devices. How much traffic increases? How much broadcasting? How much collisions will occur? More and more occurs. The more is more damage. So obviously, it is works like a half duplex mode communication type only. Okay.
Sir, that acknowledgement will be sent to every device that is connected to the hub, right?
Again, yes. Very good. Very good. Correct. Okay, next one is the networking switches. When you are searching for a switches, always search for a networking hub, networking switches like that only. Otherwise, it shows a physical switches kind of stuff. Okay, so networking switches. Yeah, this is an iconic icon, but so how the switches are there? See, the switches are also look like a hubs only. But these switches are small switches are there, big switches are there. Like this is a 5-port switch, gigabit port switch it is. This is the Netgear 8-port switch, 24-port switch, 16-port switches are there. Okay, 48-port switches are there. Okay, see these are the different type of switches. Switches and hubs are look like a same. Not a much differences by look. If you take this small switch, you don't know whether it is switch or a hub. Okay, so by look you cannot see. If you see the big one, then maybe you can think, yeah, it is not a hub, it is switch, because of switches are used for a small and large networks also. We can able to connect it. Okay, the next one is, yeah, this diagram I done. So next one is about a switches. In PPT I add a few points are there, but here I am removing some points. because I've taken some points from different resources. Okay, and that's why for you I thought it is not much important. So you know, we don't get the point. Those things. Switch is an intelligent device, guys. It understand MAC address. Switch is a intelligent device. It understand MAC address. It maintains the MAC address table. Switch ports are fixed bandwidth. Fixed bandwidth, variable bandwidths are not there here. That is, we'll do it. Of course, works in a flooding and so full duplex mode, off duplex mode. These are nonsense. Yeah, different type of switches are there, guys. Store and forward switches and cut through switches kind of stuff is also there. Okay, switch is basically layer 2 device, and we use a switch for a LAN communication. Switch is we are using for a LAN communication. Large number of devices we can able to connect it. Both small and large networks we can create it, because of if you take 24 port switch, so at least you can connect 20 plus devices, you can connect it, right? 24 port switch means 24 port connections you can able to make it. Okay, for example, you have a 50 devices, take a 2 or 3 switches, take a 3 switches. Okay, I have a 50 devices are there. Okay, around 50 devices. I have a 24 ports which is only there. Then 24, maybe another is also 24, for example. I will connect from here to here, here to here. It means out of 24, 23 devices we can connect it. One port is connecting to another switch. Okay, here two ports are for connecting purpose, then 22 devices we can able to connect it. Here again 23 devices we can connect it. So how much? More than 60 devices we can able to connect with the 324 switches. Okay, so almost like a 50 plus 46 plus 22, 50, 58, 68 devices you can able to connect it. So more than 60 devices you can connect. Okay, if you take 24, or you can take 16 instead of that one, then it is only 15. Okay, this is what I'm trying to say is you can use extended star topology in this one. You can connect a large number of devices in the single LAN communication or a single network. Number of collisions are little less. Okay, so number of packet loss is less. Of course, which broadcast initially initially means starting only, initially, and unicast later. Once MAC table using MAC table. MAC address table. I will explain what is that MAC address table. Okay, so this is called a single broadcast domain. Is a single broadcast domain and multi-collision domain. Okay, collisions will occur at port side collisions only, not switch side collisions. Switch port only, okay, not at your switch. Inside the entire switch is not having any collision kind of stuff. Okay. And of course, I will explain how the drawing it is. Okay, so guys, again, so switch is intelligent device. It understand MAC address. It is layer 2 device, which is DataLink layer. So we use for LAN communication, both large and small networks. Switch is a broadcast domain and broadcast, single broadcast and multi collision domain it is. Okay, it switch broadcast initially like a switch broadcast initially like a um, switch broadcast initially like a hub, and later it is unicast, that it is unicast using MAC address table. There is a two switch functions like a MAC address learning, forwarding kind of stuff, guys. This is a few small points are added. That is, there is a layer 3 switches also there. You said if you stand on a, sir, switch is a layer 2 device. That's it only. No, 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 guys. There is a layer 3 switches also there. Okay. Layer 3 switches also there. What is this layer 3 switches? Okay. It operates in both switch level and router level also. Means switch does not understand IP address, but layer 3 switch understand IP address and routing configurations also. Where we use this layer 3 switches, VLAN communication called inter VLAN communications, VTP, what VLAN trunking protocol, something is there. Okay, it is a inter networking communications purpose also we use it. Like it is both switch as well as a router. The router has a limited LAN connections. Basically, router has a limited LAN connection. Switches do not have any WAN connections. Understand? Switch don't have any WAN ports. Router having a LAN ports, but 2 or 3 LAN ports only. Okay, two ports are 4 port of LAN ports only. It does not have more LAN ports. But L3 switches are having both router, like a WAN ports are there, and as well as a LAN ports also there. Basically, LAN man, it is not point. L3 switch is basically a switch only. It will work like a switch only, but also it can able to do router functionality like understanding IP addresses, routing between one network to another network. Also, it can able to do it. Mainly for internally in organization, I want to divide my physical network into a different logical network separately. I want to divide it, so I use this kind of stuff. Here it is, manageable switches. Next one is unmanageable switches. Manageable switches, unmanageable switches. These are general. No need to configure. No need to configure. It is a general switches, regular purpose we are using. You no need to configure anything, just connect. Okay. This is, you can configure for VLAN communication. VLAN, VTP type of communications, you can able to do it. Okay. Port configuration, you can able to do it. So this is the manageable, unmanageable switches. For example, you join for a Cisco routing and switches. So what is that Cisco switches kind of stuff? We configure a switches there. In generally, I have in our office or maybe in our home. If you put a switch, you don't configure it. Just we connect a port and we start communicating. Okay, so we don't need to configure anything. We use the as a default switch configuration only. Okay, but manageable switches we have to connect, and if you want to configure, you can configure different configurations, port configuration, security configuration, port security configuration, VLAN configuration, VTP configuration. You can able to do it. Hub and switches differences, guys. Hub is a layer 1 device. Switch is a layer 2 device. Hub does not understand MAC address and IP address. Switch understand MAC address. Switch understand MAC address. Okay. Hub and switches both are used for LAN communication. LAN communication only. Okay. Hub is suitable for only small networks because of hub. Sorry, small networks only. Switches we can use for both small and large networks also. Hubs are broadcast domain. It broadcasts the packet to everyone in the network. To everyone in the network, it broadcasts the packets. Broadcast the packets to everyone in the network means those devices are connected to hub. It will send the packet. It is a broadcast domain. It is a single broadcast domain in a single collision domain. Of course, it broadcasts the packets. Okay. So both are single broadcast domains only because the broadcast is happen at a entire device level. That is a broadcast. Single collision domain means entire device is having a collisions will occur. Because of this single collision domain, more packet losses occurs, more collisions occurs, more packet data loss. So once packet data loss is there, of course, if you have more devices, more and more packet data loss also possible. Okay, so that is the point. And next, switches. Switches actually initially it is a broadcast to everything. Initially it is do broadcast like a hub, but later it is become unicasting the packets. Later after creating MAC address table. And a switch is single broadcast domain and multi-collision domain. It's a collision set port. And there is a layer 3 switches also there, guys. Do not ignore that point because so if you don't tell also no problem, but don't ignore it. Why? Because so you said you stand on a switch is a only layer 2. You're telling layer 3. How come it is? You are wrong. I am wrong, kind of stuff. Okay, but there is a layer 3 switches are there. It function both switch kind of functioning and as well as a router kind of functioning. Mainly these L3 switches are to create and manage the inter-VLAN routing and VLANs, inter-VLAN routings, VTP kind of configurations. So it means switches basically understand MAC address. Packets will be forward based on the MAC address base only. But here it is switch L3 switches can understand IP addresses and routing configurations also. It route the packets. That's what I'm trying to say. Guys, there is a diagram is there, no? So this is the diagram. Now, earlier this is a hub. Now this is switch, out switch. How it function, we'll see based on this broadcasting and all. Look at here. You want to send a packet to B, A to B communication. Okay. Someone sent a message. Yeah, as per the OSA layers, there is a 7 layers are there. Very good. There is a 7 layers are there. So layer 1, layer 2, layer 3, layer 4 like that. So layer 1 is a physical layer. Layer 2 is a data link layer. Layer 3 is a network layer. And fourth one is a transport layer. Fifth one is session layer. Sixth one is presentation layer. What is the top layer? Application layer. Okay. The switch comes under category of layer 1 device. Sorry. Switch is layer 2, hub is layer 1, router is layer 3. Okay, as per OSA layer model. Okay. Okay, now it is, can you see this is the APC want to send a packet to B. Okay, A send a, for example, this is a port 1, sorry, this is port 1, port number 1, 2, 3, and there is a empty port 4, 5, 6, 7, 8. Those are not connected. This is a 8 port switch it is. So this is the port number 1. A send a packet to B. A send a packet, then packet is received and packet is distributed to everyone. I said initially switch act like a broadcast. It broadcasts packet to everyone. Guys, this is a MAC address table. Okay, it is a MAC address table. This is the port number. For example, this is the MAC addresses. So what it is a port number, right? PORT. Okay, this is the port number 1. A send a packet to B, but it is sent to everyone. Okay, so then finally B accept the packet, remaining will drop the packet, right? Now what I have done, so this is a switch, what it will do, it takes the A's MAC address. Okay, it take the A's MAC address here. Okay, so for A's MAC address, I put a A1. Okay, now everyone is received a packet and they drop the packet, B accept the packet, completed. Now after some time, not after some time, normally people communicate each other. Now C send a packet to D. C send a packet to D. C to switch to D and also to everyone. Because switch don't know where is D. Now C is connected to port number 3 and the C's MAC address will be registered. For example, C's MAC address is C1. Same way, whenever these devices are communicating each other, either sending and receiving a packets wise. Yeah, okay, good. Okay, packet wise. So one by one, it will be added like a port number 2 is connected to BPC MAC address. And port number 5 is connected to DPC, okay, DPC MAC address. Okay, sixth port is connected to EPC MAC address. So this is the MAC address table. Okay, this MAC address table is created. Now we'll see the communication. I'll take another color. Okay. Now B want to communicate. B want to send a packet to EPC. Okay. B want to send a packet to EPC. So B sending a packet to switch first. Then what is the destination? EPC. What is the EPC MAC address? E1. E1 is connected at 6. Then it will forward the packet to 6 only. Port number 6 only. See this? No need to broadcast now. Once MAC address table is created, you don't do broadcasting again. It is not required because of once you know the destination MAC address, obviously when our packet is traveling to and from or from and to kind of stuff, from to means source and destination. First switch receive the packet, take the packet, check the destination MAC address and source MAC address and destination MAC address. Switch can able to check source MAC address and destination MAC address, and the destination MAC address is mapped to which switch port is there, right? So obviously it will forward packet to that port only. Okay, that's what it is. Initially it is broadcast, but once it is learn the MAC address and create a MAC address table, once it is created, it unicast. It is unicast.
Sir, that broadcasting will happen only once.
Broadcasting will happen only once, but initial time, because if in this list your destination is not there, then it has to do broadcasting. In the MAC address table, you have your MAC address is mapped to port number, then no need to do broadcasting. For example, new PC is added to the 8th port, and this is for example FPC. Now A to F packet. F is not mapped here. So then do first broadcasting. Once it is LAN, you do unicasting. Okay, good. One point that is because forget, but why it is called as a single broadcast domain and multi collision domain. Okay, so why it is called as a single broadcast? Because entire switch is a collision, a broadcast domain. Entire switch is a broadcast domain, like a entire hub is a broadcast domain. Multi collision domains, single collision domain, and this entire hub is a collision domain because of all packets traveling through this hub, irrespective of what port it is. Okay, so that's why it is single collision domain. If you take switch, because of this unicast, for example, I have a BPC, A send a packet to B. Same time, C is sending packet to B. So this is single port only, right? So port number 2 receiving packet from A and as well as a C. So collisions occurs at each port while it is communicating. So there is a possibility of packet data loss, but still not much as hub. Okay, not then that many packets won't be collide here. It is very less packet collisions. So data is secure. And of course, we can secure in a different ways also. Okay, using MAC address manageable switches, you can do port security also, port management, port security management, port security kind of stuff also you can do it. We don't allow unauthorized people to connect. Okay. So this is hub and switches, guys. Okay, so find out easy differences, and I will go for a router. Up to here, okay, guys? No problem?
No, sir.
Sir, I have a question.
Yeah, tell me.
Sir, while I was searching for the difference between switch and hub, I get to know that it's very tough to hack device connected via hub, but it's very easy to hack those devices which are connected by switch. So, but why it is so? Like a device is connected with
Okay,
hub is
so you
easy
use
to hack in other.
that is actually hack no hack kind of concept it is. But if you take hub and switches, security is different, hacking is little different, but still anything can be hackable, so no difference in it. But hub is it is reverse point, guys. Hub is do broadcast, right? For example, in my private network, who can able to sit in my LAN? The trusted people only, not outside people, right? You go to cafe means that coffee shops are there, na? Okay, McDonald something is there. I don't names difficult to spell for me. Usually I don't go there. Very less because cost is more. So yeah, at that time also completed for me. Okay, so point is, for example, this is the hub. Okay, so when you are connecting to the public network, anyone can be sit in your public. So that's why I'm telling. So you go to hotels or restaurants or this coffee caves kind of stuff is there. They you give a free Wi-Fi for some time. Okay, earlier days people do not have this 4G kind of connectivity data speed. So compulsory people who sit there and eat or drink for a more time. So then obviously they need a network connection. So they give their public. Even railway stations, they are giving a public network it is. So someone hacker is sitting in this public, so they can try to attack you because both are sitting in the same network. Okay, but in offices, homes, all people are trusted people only. So whether it is hub or a switch, no difference. But point is here, guys, hub broadcast, right? So any packet it receive, it broadcast. For example, I am a hacker, okay, hacker or kind of stuff, okay, hacker. I want to collect all the packets in the network. So I put this, I connected to this hub, and people who put a packets, this is all are broadcasting, right? So every packet is broadcasting everyone, and as well as everyone is while they are sending to someone A to B communication, but I will receive that packet. A send a packet to D, I will receive the packet. A send a packet to C, I will receive it. Generally, when I receive, I have to see destination address. If it is not belongs to me, I will discard. You receive a letter which is not belongs to you. What you will do it? It is not mine. You throw it away or you send it back, right? So here it is. When I received a packet, my device is received a packet, it see the destination address. It is not belongs to me. Destination address means to address. I check the to address and I will discard. It is not belongs to me. I will drop the packet. But this hacker is sitting here, receive all the packets, and he can able to check all the packets content. So that is not at all secure one. Switches, initially there is a broadcasting point. Initially it is do broadcasting, but once MAC address is learned, so what it will do? It is unicast. A send a packet to D, directly D. I'm sitting here, I don't receive any packet from A. Okay, I didn't receive A to D packet to me. In hubs, I can receive. In switches, I can't receive once the MAC addresses are learned. So it is secure than hub in that context. Okay. Next one is MAC spoofing is there. If in case this hacker is more intelligent and start putting a MAC spoofing, it means in this port he listed all the MAC addresses. What are the MAC addresses are here? All the MAC addresses are there. So obviously A want to send a packet to D. and then A to D as well as A to here. Okay, so then it is little difficult now. So we have to put a max spoofing here. Okay, so in a secure line, it is securely we will attack. An unsecure line, unsecurely we can able to attack. That's the point. Okay, that's it. Okay, here guys, here it
Thank
is. Yeah, tell me. Yes, sir. Hmm? Sayang nahi. వస్తాను 1 minute.
5 minutes.
1 minute.
5 minutes.
అలాగే బ్రేక్ ఇస్తాను చాలా చెప్పాను. Sorry guys. Start. You're telling some. Okay. So this is a bridges, guys. I will tell bridges and we'll take a break because I am talking from last more than 1 hour. Your brains also get heated. So definitely we'll do part 2. That is routers and modems and this SOHO kind of configuration. The Wi-Fi multiple things are there now. That is. I will tell this is a very small point. Bridges. There is no physical bridges are not there, but mostly the switches and bridges, the difference is given. Normally switches having more ports used for single topologies, single segment type of communication. You know, these are bridges are very important, but not we are using in regular time. Okay, so bridges usually bridge between two different networks. Okay, two different networks we can bridge it like a routers we are using same way we use a bridge kind of stuff. Most of the bridges are a software bridges also we can use it. Okay, most of the bridges are a software bridges to communicate between the two topologies kind of stuff. And of course virtual network bridges also there. Nowadays, network virtualization concept is nothing but this network virtual bridges. For example, I have a virtual machine. I have a virtual machine in my laptop and I have a physical network is there. My Wi-Fi network is there. Now this virtual machine want to communicate my physical network means internet is required. Then it is connected to a virtual switch. This virtual switch, virtual adapter is bridged to my physical NIC. This virtual NIC is bridged to physical NIC. So like that, this one is also will get internet, physical network access. So this is a bridging concept. Bridging means connecting two different networks or two different NICs, physically or virtually connecting concept. Okay. Yes, next we will see about a router. So after a small break, just take a 10 minutes break, relax, have something, then we will do it. Okay. Router switches, sorry.